Thank you for such a warm welcome. It's an honor to be here in Dubai. This is my first time visiting Dubai, actually, and I'd like to take this opportunity to thank the organizers of GTEX and the Dubai World Trade Center for inviting me over here and giving me an opportunity to speak my heart out in front of such an esteemed, knowledgeable, and renowned audiences. So my name is Pranay Pathole, and I'm a data science grad student at the University of Texas at Dallas. The topic that I would be speaking about today is building machine learning and neural net models using PyTorch. So basically, before we dive into that topic, we need to know what machine learning is. So machine learning is essentially a field of study where you can give computers the ability to learn by themselves without being explicitly programmed. How that works is you'll show the computer the data and the associated labels. In machine learning language, we call it features and labels. So we show the features and the associated right answers, which are labels, to the machine learning model. And through that, it tries to find patterns. And that is essentially what machine learning is in a nutshell, to find patterns. And then after that, we show the machine learning model with some unseen and never before used data and see if that machine learning model is trying to predict the right answers or not. If it is predicting the right answers, then well and good. But if it is not, then you need to make some changes. You need to do hyperparameter tuning and a lot of stuff to get the model's accuracy or machine learning model's accuracy higher and try to get the ideal output out of it. So the learning technique that I just described right now basically is encapsulated by supervised learning technique. Then there is unsupervised learning technique over where we just supply the machine learning model with features, and we don't provide it with the labels. And a machine learning model will try to identify the labels on its own. One popular example is clustering mechanism, like k-means clustering. It is one of the popular unsupervised machine learning algorithms that we use from time to time. And then there is transfer learning technique, and then there is reinforcement learning too. So that is pretty much what machine learning is. This is the basics of machine learning. So moving on. So I'm constantly fascinated by how powerful machine learning frameworks have evolved. I mean, if you look at the code from the left, in order to implement a neural network from scratch, you had to write almost 200 to 300 lines of code with all the math, linear algebra, probability, calculus, statistics, everything included. This was during the time when machine learning algorithms, machine learning frameworks such as PyTorch, TensorFlow, scikit-learn were not much evolved. But now they have gotten super evolved that they have reduced the dependency of math that you need to programmatically implement in the code. You can straight away import PyTorch, and within 50 to 60 lines of code, you can build a very powerful neural net classification algorithm. So this is something really fascinating and intriguing to me, that how quickly technology is being evolved right now. In fact, this is one of the conversations that I had with Elon when I got the privilege to meet him back in August of this year. I asked him what does he think about machine learning frameworks such as PyTorch and TensorFlow being evolved so much and reducing the need of math required in the code, as PyTorch is popularly used at Tesla for their autopilot and full self-driving software. So he was like, it is the implementation that matters. It is good that the math dependencies are being reduced from the PyTorch frameworks and from TensorFlow frameworks. A lot of people from non-STEM background can get into coding and start building some powerful models seamlessly using PyTorch. So it is the implementation that matters. And yeah. So moving on. So this is what basic PyTorch workflow looks like. In fact, not just a PyTorch workflow. This is what basically any machine learning workflow looks like. So first is getting data ready into the tensors. So basically, tensors are intuitively supported by PyTorch. Tensors are nothing but, you can consider tensors as arrays of numbers, because computers work well with numbers rather than text or image data that human minds can comprehend. Computers cannot. So we need to convert them into a computer-readable format. And getting your data converted into tensors is the first step. Then you need to build your model, pick a loss function and an optimizer, create a training loop, then try to train the model and make a prediction. Then evaluate the model using some evaluation metrics, see how the model is performing, find out the model's accuracy, precision, recall, F1 score, confusion matrix, etc. And then if you don't like the results, you can obviously improve through experimentation. As I said before, you can apply some hyperparameter tuning and change the parameters, run the neural net model for more number of cycles, for more epochs. And then, of course, you can save and reload your trained model. This is what a basic PyTorch workflow looks like. Next is data preparation and loading. So the data in machine learning could be of any format. It could be huge spreadsheet numbers. It could be images, or images of any format, JPEG, PNG, doesn't matter. The data could be videos. YouTube has tons of data available. The input could be your audio files, such as podcasts or songs, or text, where you can apply some natural language processing. And of course, you would have your numbers. So first thing is converting your data into some sort of a numerical encoding or some sort of a numerical representation that will help your model learn even more efficiently and even more better. And then basically how I like to describe it is machine learning is a game of two parts. First is picking the data, trying to convert it into a numerical encoding format, and then just building the model. So preparing the data is one of the crucial factors in machine learning, and it affects a lot on your accuracy score and how your machine learning model would look like. So preparing the data is very important. So let's say we want to build an image classification algorithm using PyTorch. So in this example, in this code, as we can see, I have used Fashion MNIST dataset, which is a very popular beginner-friendly dataset. If you want to get your hands dirty, you can start with the Fashion MNIST dataset. And setting up, this entire code basically represents how you can set up your training and testing data. So training data, the parameters taken into consideration are root, where you want your training data to be stored. The parameter train is equal to true. That means this particular data is training data. Then the line number 6, transform is equal to 2 tensor, is something that I like about PyTorch, is because you can seamlessly convert any sort of thing, any sort of data into numbers with just a single line of code. So that is really powerful. And even TensorFlow has a similar functionality. And then setting up the test data is, of course, root, where you want your data to be trained. This time, the trained parameter needs to be false, because this is the testing data. And then transform is equal to 2 tensor, which is basically a numerical encoding of any type of data that you want to train your neural net model on. Now that we have got our data ready, there is a very powerful feature included in PyTorch, which is known as PyTorch Data Loader. What basically PyTorch Data Loader does is, as the name suggests, it helps loading of data to a neural net model much more easier. That is the first functionality of Data Loader. And second functionality, which is super crucial, is that it divides the data into smaller batches or smaller chunks so that your machine learning model could learn much more efficiently, and it is computationally less expensive. So that is a super cool feature that PyTorch has got. So batch size is equal to 32. Batch size is basically what the chunk size is. Suppose you have a very large data set and you want to divide it into chunks of data or batches of data. That is what it specifies. Batch size is 32. You usually increment it in the powers of 2, but 32, 64, 128, so on and so forth. Then there is the train data loader, which takes into consideration your training data, your batch size, and shuffle is equal to true, so that every cycle, your machine learning model will get to train on the new data. And then there is the test data loader, which takes into consideration parameters as test data, batch size, which is equal to 32, and then shuffle is equal to false, because we don't have to shuffle the testing data. Next step is creating of the CNN model. CNN is basically convolutional neural network. It is extremely powerful for classifying visual types of data. And as you can see, that I have created 3 layers of Conv2D. Conv2D is basically your convolutional neural network. Why I have used 2D is because my image data consists of height and width, so therefore it is 2-dimensional, so therefore it is 2D. You can even train it on 1-dimensional data or even on 3-dimensional data using Conv1D and Conv3D respectively. So there are in channels, there are out channels, there is the kernel size, stride, padding, and after that I have also added a nonlinear activation function, which is nn.relu, which is rectified linear unit for classifying of nonlinear data. And then there is the max pool 2D, and the second layer is exactly the same as the first one, and third is just the classification layer. And the method that you see on the line number 36 is the forward pass that you essentially have to do while training your neural networks. Whoops. Sorry. Yeah. Then we need to set up our loss function and an optimizer. What basically loss function does is tries to tell you how much your predicted outputs differ from your actual output. It tries to measure how wrong your model's outputs or your model's predictions basically are. Because what neural network algorithm, neural net model is trying to do is it is generating random numbers, it is generating random tensors. It is basically like a gradient descent where it starts off with a random number, then it sees how far away it is from the actual or the desired output, then it tries to minimize the loss using the optimizer. So that is what loss function is doing. And PyTorch has different type of loss functions available for your different type of problems that you face. So nn.cross entropy loss is basically used for multi-class classification, as fashion MNIST data set consists of images that don't just belong to 2 classes. They belong to 10 or 11 classes. So that is why nn.cross entropy loss. Now, if you want to do binary classification, you can use nn.bc, which is binary cross entropy loss. And then there is the optimizer, which basically tries to optimize the loss and tries to get you as close as possible to the desired output, to the desired or predicted output. So then we need to create the training and testing methods. So the training method consists of calculating of, firstly, we need to do the forward pass. In the forward pass is where your model goes through all the training data at once. And that is what forward calculation is essentially doing. Then you need to calculate the loss, see how inaccurate your model's predictions are. That is what train loss is. Your loss should be as low as possible, and your accuracy should be as high as possible. Then you need to reset your optimizer. That is what is being done in the third step, which is optimizer.zeroGrad. And then you need to perform backward propagation, loss.backwards. And then you need to step up your optimizer. So these are the essential 5 steps that you need to perform in order to build any sort of a neural net model in PyTorch. So testing method is basically a way of evaluating your model, how your model is performing on the testing data, how your model's accuracy is on the testing data. One major issue that we face in machine learning is the problem of overfitting, where your training accuracy is higher, but your testing accuracy is very low compared to your training accuracy, which is a major problem that we face in an ideal machine learning scenario, which needs to be optimized and which can be tested using this particular method. In order to test your test loss and your test accuracy, we need to write this particular loop. And then there is actual training of the model. As you can see on line number 8, epochs are basically your cycles, how many times your machine learning model or how many times your data has to pass through your neural net model in order for your neural net model to learn it much more accurately. So epoch is basically a hyperparameter. You can modify it according to your will and your problem statement, or how much you want your machine learning model's accuracy to be. If you're not satisfied with the machine learning models, if you're not satisfied with your machine learning model's accuracy, you can, of course, increase your epochs and run it for more cycles. Though it would be running more number of epochs is computationally expensive on the GPU. Of course, you can start out with a low number and then gradually keep on increasing the epoch if you're not meeting your desired accuracy. And then you just need to pass your training step method that we just created in the previous slide and your testing step method. And you just need to write it inside a loop. And the loop will run for 3 times. And that is basically it. That is how you create your first neural net model. These were the only steps that are required to create your machine learning model. Then the future steps, of course, would require predictions, predicting how well your machine learning model is doing, passing your machine learning model with an unknown or unseen data, and see whether you're getting the desired output that you want or not. And you can apply evaluation metrics to know the accuracy, precision, recall of your machine learning and neural net model. And of course, you can do hyperparameter tuning. Yeah, that is pretty much it. So yeah, I would like to once again thank GTEx and DWTC for giving me an opportunity to present myself and speak my heart out in front of such an esteemed audience. It's truly an honor for me. So thank you so much.
Fantastic. Thank you so much. That was a great in-depth presentation. I think you get an extra well done for putting up with the party developers outside that are already celebrating the winding down. Amazing. So I'm going to turn to the audience now and ask if you do have any other questions for our speaker. If that's fine for you, we'll hand over the microphone.
Hi. Sure. I'm Aditya Damani from Autosys Industrial Solutions.
Hi.
We are basically an industrial automation company. One of the biggest challenges that I face is, let's say I have an IoT device, okay, that is generating data every second. So effectively, if I look at one parameter, I have 86,400 data points in a day. Multiply that by 10 parameters. That is the bare minimum that we pull from one machine.
Right.
Now multiply that by over 5,000 machines that we have got connected. Now my challenge is that while all the data is being generated in real time, I am trying to train a model in real time. So a continuous streaming to my trained model. And at the same point of time, how do I ensure that I'm using that trained set for predicting values?
Okay.
So you see, there's no termination to my code.
Yeah.
Right? It's an ongoing.
So it is a continuous process that you're requiring for.
Yes.
Yeah. Yes. So may I ask which framework are you currently working on?
So we are using TensorFlow.
TensorFlow, okay.
Yes.
Yeah. You need it in the real time, right? So I think this is it depends upon your data. Like what type of data are you training it on? Because real-time training of such massive amounts of data is super tricky, and that is the reason why Tesla had to develop their own in-house processing unit known as Dojo, because they were not able to keep up with huge amounts of data that were flowing in through the 8 simultaneous cameras while their autopilot or full self-driving is functioning. So it gets super tricky to train such a model with such massive amounts of data. So what type of data are you currently working on? Is it textual data or is it like videos?
No, it's mainly numeric data.
Numeric
so it could
data.
Be something like the speed of the spindle, the RPM,
right.
The temperatures, pressures, various process parameters, the production cycles, and a lot that has to do with industrial machinery.
Mm-hmm.
The problem is the machine does not stop. It runs 24 hours.
Yeah.
So it keeps on generating data, and I have an abundance of data that I'm trying to train, but I'm unable to achieve, touch that point.
Right, that makes sense, yes. So have you thought about using some sort of a cloud platform and then storing that data on the cloud and then trying to train your machine learning model?
Well, the data is on the cloud.
Data is on the cloud, right?
What my challenge is, how do I have or implement a neural network or any
machine learning model
where there is a continuous streaming into my feeding of the data, in the training set,
Right.
while I can also use the same as an object or an instance in my testing or predicting set. That
No,
is
that-
my main fundamental challenge.
Right, yeah. So basically you need it for the real time, right?
Precisely.
Yeah, yeah. Real time it gets super tricky, as I said before.
Any thoughts, any leads, anywhere where we can probably dig in and try exploring?
I think you can look for TF2. I have done some real-time training data, but it was done on very low amounts of images. Let's say somewhere around 300 images or something, where I was using OpenCV and I was using k nearest neighbors to classify those particular images. But it was based on the mobile application. So the amount of data flowing in was really low. So that's why I was able to handle it. But in your case, as you said, that you have tons of data that is flowing in, it might create some sort of latency issues, or your model will not be able to handle that amount of data. But then again, you can look for, there are some modules or functions that are available in TensorFlow known as TF2, I think, that you can use for your real-time streaming of the data.
Got it. Can I set up like a Kafka and stream it directly through that?
That can be done, yeah.
DF2 you said, right?
Yeah.
Thank you very much.
That can be arranged, yes.
Awesome. And I have a question for you as well. As someone that met Elon Musk as recently as August, he recently tweeted out about X application. As we were talking today a little bit about AI on social media platforms, do you have any expectations for XApp and maybe anything that as viewers can take away for today?
So what basically XApp looks from Elon's vision is he is super inspired by the WeChat that is already available in China. So basically people live on WeChat. In WeChat you can obviously text, you can use social media, you can do payments. That is what Elon's vision is with the X, and that is why his main ambition to acquire Twitter, to convert it to X, comes from. Mainly, I would be interested to see how his payments platform would look like, because he has already worked on a payment portal before, PayPal, X.com. So I think it would be interesting to see how it goes. I'm looking forward to his acquisition of Twitter.
Yeah, I think everyone is. And would you be expecting crypto to be integrated in that payment?
Of course. I mean, he's a huge supporter of crypto, mainly Dogecoin. So I think, and he and Billy Marcus, they are close friends. So I think I would not be surprised to see crypto functionality being implemented in the X application.
So watch this space. Fantastic presentation. Thank you
Yeah.
so much. A
Thank you
final
so
round
much.
of applause for our final speaker of today.
Thank you. Thank you for having me on. Thank you so much.
you.
Yeah.